Okay, this is going to be the second video about work and energy. So recall from our last video, we were in outer space and I had this one ball that was moving and it collided with this other ball that was at rest. And we labeled them ball A and ball B. We said that ball A, right, when they collide, exerts a force on ball B. Ball A exerts a force on ball B over this distance, right, kind of when they're colliding. And so ball A does work on ball B. Ball A does work on ball B, which means that ball A transferred energy to ball B. And we see that because ball A loses some of its velocity, and now ball B has picked up a velocity. And the way I explained that was now ball A has less velocity, so it is less able to apply forces to other objects. And ball B now has a velocity where it didn't before, and so now it has an ability to collide with something and then transfer some of its energy to something else. Let's think about this actual collision though. So remember Newton's third law. So if ball A is exerting a force on ball B, right? So this is ball A on ball B. It means that ball B is exerting a force on ball A, right? And they're equal in magnitude. And so they're both going to be doing work on each other, or so to speak, right? Because there's going to be a distance for both and a force for both. For ball A, the distance is going to be this way, right? So ball A is going to do positive work. And ball B, right? So now ball B is exerting a force on ball A, but it's going in this direction. But the distance over which that force is applied is in this direction. So ball B is going to do negative work. So let's think about what the positive and negative means. So if ball A does positive work on B, it means that ball A transfers energy to ball B. If ball B does negative work on ball A, what it really says is that ball A is doing work on it, right? So we've just kind of rephrased it. From ball B's perspective, sure, it's doing work on ball A, but it's negative. And what that really means is that ball A is doing work on it. And if ball B is doing negative work on ball A, right, and we put a number to that, so say it's like negative 10 joules, that negative 10 means that it's actually gaining 10 joules of energy from ball A, right? If work is a transfer of energy and B is losing negative 10 joules, then just like in algebra, if it's losing negative 10, like subtracting negative 10, it's really gaining 10 joules, and that's because ball A is exerting a positive work, right? A positive force, so it does positive work on ball B, so it transfers energy to ball B. And another example that we can use just to think about it is if you lift up a box, right? So we exert a force on it, and it travels a distance, and it was at rest before, and it's at rest when you've raised it up. So now it's up here. It took me work to do that, right? And we could figure out how to calculate that. And we would use this formula, mass times acceleration due to gravity times distance, because we're going against gravity. I'm saying, okay, I transferred energy to that box. How can that box do more work now? What have I done to know that the box can do more work? It's like, well, let's see what happens if you let go, right? So the box, before you lifted it up, before you did work on it, before you transferred energy to it, it couldn't really do much work on anything, right? I can't really see it applying a force or something over a distance. But after you apply work to it, so you've lifted it up, you've increased its energy. Now if you let go, that can definitely apply a force over a distance, right? And this is another way just to see that work is a transfer of energy. So by lifting the box up, I transfer some of my energy to the box, and now it can transfer energy to something else.